2 of the practice test. The answers are as follows. Have the right writing utensils ready. Number 1. They gave you a fraction of decimals percent. They gave you the fraction of 3/4. The decimal is 0.75, or 0.75, and the percent is 75%. Number 2, they gave you the decimal of 0.48. The fraction is 12 over 25. It was 48 over 100, but you need to reduce. And the percent is 48%. Number 3, they give us 2.8%. If you work backwards, the decimal is 0.028. If you put as a fraction 28 over 1,000, that's correct, but you have to reduce it. It's 7 over 250. 7 over 250. Number 4, they gave us 2 over 11. The repeating decimal is 0.18181818, so basically 0.18 with a repeat bar over both. And the percent is 18.18 repeating percent. 18.18 repeating percent. Number 5, they give you a repeating decimal of 0.7 repeating. The fraction is 7 over 9. The percentage is 77.7 repeating percent. Number 6, they gave you 36.36 repeating percent. The decimal is 0.36 repeating. If anybody had 0.3636 with the 36 repeating, that's okay. It's the same thing, it's just more than you need. And the fraction is 4 over 11. Number 7, the percentage is required, the fraction is extra credit. The percentage is 16.6 repeating percent. And the fraction is 1 over 6. Can you repeat to number 7? Yeah. Oh.
What was the percent for 7?
Percent for 7 is 16.6 repeating percent. Any other repeats? Yeah, Max.
What was the fraction?
For what?
7.
Number 7? 1 over 6.
Okay, thank you.
Anybody else? Front page? All right, next page. Number 8 is rational because it's a repeating decimal. That's all you have to put. You do not have to actually give me the fraction, although that'd be lovely, but it's probably more time than you need. Number 9 is irrational. Number 10, rational, because the decimal terminates, it stops. Number 11 is irrational. 12 is rational, because you can write it as -4 over 1, or because the decimal terminates. Number 13 is rational, because it turns into 1 over 3. 14 is irrational. Basically anything that has pi in it, or that has a radical in it, unless it's a nice radical, is irrational. Yeah? 13 is rational, because it boils down to 1/3. 14 is irrational, and 15 is rational. It's like 118 over 3 or something like that. Oh yeah, whoops, yeah. 178 over 3. Yeah.
For 15, if I just said, like on the test, and said it's in fraction form, then that would be
It's actually a mixed number of things, but not fraction form. But it can be written in fraction form. Max.
What were 8 and 9?
Hang on. 8 was rational, 9 is irrational. And 8 is rational because it's a repeating decimal. So you'll have to give a reason for any repeats.
What was 15?
15, rational. And that's because you can write it as a fraction. Any mixed number you can convert to a fraction.
What would the fraction be?
We're going to just say 168 over 3. 178. Yeah, that's right. 178 over 3. I don't know any answer to so I can do questioning. Okay, next page. Oh, this is going to be fun to do in my head. Formulas for circumference, C equals 2 pi r. You could also have C equals pi times d. Either one is fine. Number 16, circumference of a circle.
Oh.
Number 17, what is the formula for the area of a circle? A equals pi r squared. Now the fun begins. Yeah,
Is it capital A?
it is capital F, correct. And it's capital C for circumference. Yeah.
Would you take off points if we didn't use these both are 84?
I would. Yeah, it's part of the formula. Number 18, the radius is 10. That makes the diameter, 10 inches rather. Makes the diameter 20 inches. Makes the circumference 20 pi inches. And makes the area 100 pi square inches. And it repeats on that. Yeah.
For the area, can you say inches squared?
Inches squared is fine. Yeah. Any others on number 18? Number 19, the diameter is 18 centimeters. I would go back and get the radius, which is 9 centimeters. Then the circumference would be 18 pi centimeters. And the area is 81 pi square centimeters, or centimeters squared. And it repeats on 19. Yeah, like,
Can you do the circumference and the area, or no, the diameter and the area, please?
okay, the diameter they gave you is 18 centimeters. The circumference is 18 pi centimeters.
Oops. That was a bit wrong, never mind.
Okay. Everybody get an answer for? Number 20. The circumference is 30 pi feet. You can go back and get the diameter, which is 30 feet. If that's true, then the radius is 15 feet. You can use that to get the area, which is 225 pi square feet, or feet squared. Joe? Okay. And it repeats on number 20. Alrighty, number 21. 25 pi millimeters squared. You can go back and get the radius, which must have been 5 millimeters. If the radius is 5 millimeters, the diameter is 10 millimeters. And if the diameter is 10 millimeters, the circumference is 10 pi millimeters. You ready for that? Number 22. 2 pi square inches. You got to go back and find the radius, which is radical 2 inches. Radical 2 inches. Then the diameter would be 2 radical 2 inches. And the circumference is 2 radical 2 times pi inches. You could also have 2 pi radical 2. Just make sure that if you have 2 radical 2 pi, put parentheses around the 2 radical 2, so it doesn't look like pi is getting square root. And it repeats on 22. Okay, 23. If the diameter is 6 pi, the radius is 3 pi yards. The circumference is 6 pi squared yards. 6 pi times pi. And then, 23, the area would be 9 pi cubed square yards. 9 pi cubed square yards. Okay.
What was the radius between
3 pi yards. Make sure you have yards. Atom. Circumference was 6 pi squared yards. Plain old yards. Go.
Why would it be 9 pi cubed square yard? Wouldn't it just be
Okay.
9?
Well, you start with 9, you start with the radius is 3 pi. So square that. 3 pi times 3 pi is 9 pi squared. And it's pi times radius squared. So pi times that. So take 9 pi squared times pi, and it'll make 9 pi cubed.
Okay, but why are the yards square?
That's for area. Yards are, area is always square units.
Yeah, it says squared before.
Yeah, a lot of people looked at the pi cubed and thought they must be cubic units or something like that. They're not. They're plain old squares. Number 24, which is the totally fun one. The circumference is 4 inches, no pi. That's pi times diameter. So the diameter must have been 4 divided by pi. 4 over pi. This is actually good that way. So the diameter is 4 over pi. The radius must be 2 over pi. And then the area, which would be, let me see, 4 over pi squared times pi. So it'd be 4 over pi square inches. 4 over pi square inches. And we did on 24. Alright, next page. Suppose a circle is inscribed in a square like so. If the radius is 10, that means that the diameter of the circle is 20. It also means that one side of the circle is all the way across the square is 20. So the area of the square is 20 by 20, or 400. The area of the circle is pi radius squared, or 100 pi. So the formula it should give me is 400 minus 100 pi. And it should have square centimeters. Does that make sense? 26 through 30. 26, are the rational numbers closed under division? No. There is one exception. Most of them are fine. There's one that would cause a problem. 0. That's a rational number. You divide by it, you have a serious problem. If I had put non-zero rational numbers, it would have been fine.
It's just really
I said 22 over 7 as in pi.
22 over 7 is only an approximation of pi. Yeah, that's why we don't use fractions for pi. 22 over 7 is like 3.14, but then the decimal is wrong after that. So yeah, I remember learning that in whatever grade it was, and then learning to my shock that 22 over 7 wasn't actually pi. So I'm with you. Any other questions on 26? Okay, 27. Are the whole numbers closed under addition? Yes, they are. 28. Are the positive odd integers closed under multiplication? Yes, they are. 29. Are the positive rational numbers closed under square rooting? Yeah, ignore the taking the reciprocal thing. That was a cut and paste error there. Let me just delete that. This is so stupid. Yeah, I don't blame you. That was just cut and paste. Dumbness there. On a positive rational number, yeah, square rooting is not the same as taking. Are the positive rational numbers closed under square rooting? The answer is no. For example, 3 is a rational number, but square rooting it is an irrational number. Number 30, are the non-zero real numbers closed under division? Answer, yes, they are. Is a real divided by a real, as long as it doesn't blow up, is still real. Yeah.
Wait, can you explain why 29 is no?
But 29 is no? Yeah. If you take a fraction and square root it, it's almost always going to be irrational. It's going to escape the rationals, unless it happens to be a perfect square, which is unlikely. Yeah. All numbers that exist. It's absolutely everything. Including the integers. Yeah. Any other questions up to number 30? Yeah. 25. Hang on a second. 25 was 100. Oh, sorry. I take that back. 400 minus 100 pi square centimeters. Right.
So like in log 400 centimeters squared minus 400 pi centimeters squared?
That's fine. Any other repeats up to number 30? All right, extra credit. If the circumference is 17, find the area. If the circumference is 17, the diameter is 17 over pi, which means that the radius is 17 over 2 pi. If anybody used a decimal, ew, but I suppose I'll accept it. I'll give you that in a moment. 17 over 2 pi, square that, it'll be 289 over 4 pi squared, multiplied by pi. Ouch, this is very 289 over 4 pi. 289 over 4 pi square centimeters is the answer. 289 over 4 pi centimeters squared. Use the picture and measurements of number 25. Somebody needed to, yeah, go.
Can you do the decimal for
Yeah.
Oh, right. Okay. Yeah, 17 or 289 over 4. 72.25 over pi. Actually, go to number 2. If you traced every last border in the picture for number 25, what distance did they cover? Give an exact answer. That's basically all the way around the circle and all the way around the square. So it's the circumference plus the perimeter of the square. The perimeter of the square is 40 centimeters, and the circumference of that thing is 20 pi. So your final answer should be 40 plus 20 pi regular centimeters.
Wait, no.
1 and 2, go. Yeah. Yeah.
Yeah.
Oh, heavens, the regular truck. Sorry. You're right. Sorry. Yeah, thank you. That's what happens when I don't know what to do. Yeah, 80 plus 25. Regular centimeters. Are you okay with that one? 80 plus 25. 80 plus 25. Please write that down. 20 pi. Anyway, next, go to number 3. What's the reduced fraction for 4.003? This is actually, I'll just show you how to do it real fast. If it were just plain old 3, it would be 3 over 1,000 here. But it's repeating, and it's delayed 2 spaces. This is 3 over 900. So if you want to put this over 1, make the common denominator over, I can reduce this actually. This is 1 over 300. So if I make this a common denominator, 300, this is 1,200. So it should be 1201 over 300. Yes, I did too. Are the imaginary numbers closed under squaring? Answer, no.
Nice.
If you take I and square it, you get -1, which is weird.
You do?
You just get like,
17 squared. You go 32 teams squared.
Go. Oh, question. Sorry, repeats. Anything else? Repeats. All right, questions? Yeah.
What do you do? 25.
25.
Yeah. Keep getting this one. Here.
So the one with the circle and the square?
Yeah.
Okay. They said the radius of the circle is 10 centimeters. I would draw it like that. Don't draw a slanty diagonal line. That doesn't have much use. You could go straight up or down, I suppose. This is the radius. Anybody tell me the diameter? Go. 20. Does it make sense that the diameter is exactly the same as the width of the square?
Yeah.
All the way across the circle is the same as all the way across the square. So this is 20, and this is a square. This must also be 20. Because the square has equal sides all the way around. So what I need is, if I want to get this area, I want to take the square and then cut out the circle. So the square minus circle. The area of the square is 20 times 20. And then the area of the circle is pi r squared. Is pi times 10 squared. This will be 400 minus 100 pi. And then this 70 squared. Next. Another one. Yeah. Number what? 7. Okay. There are 2 ways to get that. 0.16 with the 6 repeating. I did suggest early on that if you have a delay, there's 2 ways to do it. One way is just set this equal to x. If you have a delayed repeat, you have 2 steps to do instead of 1. Capture the non-repeating part. You have to multiply by 10 to do that. So 1.6 repeating is equal to 10x. That's the middle step. Now, capture one repeat. Remember, this is still going 6, 6, 6, 6, 6, 6, 6, 6. So this would be 16.6 repeating. Do you ever see why? So you just pop one of the 6's out. Is equal to 100x. Because you just multiply by another 10. Now subtract the bottom 2. So minus 1.6 repeating and minus 10x. You're going to get these cancel. 15 equals 90x. Divide both sides by 90. And this reduces to 1%. Yeah. I'll show you the other way if you want.
I have a question for you.
Go.
So for the second page, for 4 and 5, the percent, how did you do this?
Okay. For number 4.18 repeating, it could be a bit of a challenge. Because when you scoot it over here, you figure, well, what's here? I would write it the long way. Now move it 2 spaces over. It should look like 18.1818%, which you can write as 18.18 repeating percent. That's what it did that. Same thing with number 5. I just read it along. Max, then Joe.
So can you do number 24?
Which one?
24?
24? Hang on a second. Okay. That's the extra credit one?
Yes.
Okay. So they gave you a circumference of 4 inches. So they wanted radius, diameter, circumference, area. The circumference is 4 inches. Now, there's 2 ways to get the next thing. Can anybody tell me which piece would be easiest to get this one? Which one is most closely related to circumference? Actually, two possible ones. There's one I would definitely not get first. Area. Area and circumference don't have a direct link. Yeah.
Diameter would be easier.
I'm sorry, second.
Diameter.
Yeah, diameter. The circumference is pi times diameter. So pi times something is this. Let me just write that out. 4 is equal to pi times diameter. Can somebody get diameter by itself? Max, go for it.
4 pi.
How did you get that? Looks like you read off my answer.
Yeah, I did.
Okay. Get d by itself. What do you get rid of?
I don't know.
This is pi times d. Just think of it as an algebra problem.
Divide by pi.
Divide by pi
Oh my gosh.
on both sides. That's 4 over pi. So there you go. 4 over pi inches. Did anybody find the radius based on that? Go.
Yeah, so,
How'd you get that so fast?
just, it was half 4.
Right. Take half of 4 over pi. If you ever want to get half of anything, multiply it by half. And the 4 and the 2 reduce to 2 over 1. 2 over 5. Can anybody find the area based on this? Yeah.
4 over pi inches squared.
How'd you get that?
I squared 2, I squared 2 radical, 2 over
That's it.
pi,
Yes.
and
So you
then,
square that,
and then,
and then multiply it by
pi.
pi. So pi times radius squared is this. It's going to be pi times 4 over pi squared. One of the pi's will cancel. It'll leave 4 over pi. Just don't forget to put square inches. Next. Yeah, good.
You do the fractions for number 6.
Number 6, yeah. Somebody's messaging me. Stop messaging me. So I'm sorry, which one, number 6, you said?
Yep, the fraction.
Okay. Number 6, the fraction. Good, 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 good. All right, so we've got 0.36 repeating. The easiest way to get this, if it's a plain old repeating thing with no delay, you can fill the bottom with 9s. 36 over 99. And then reduce it. 9 goes into both of these, so divide both these by 9. This should be 4 over 11. Next. Yeah. Good.
Can you do the fraction for number 7?
Number 7?
Mm-hmm.
I think I did it already, but I can do it again. I don't know if I did or not. Actually, yes, I did. But actually, it's right here. I'll show you another way to do it, though. You get to choose whichever way you want. This is the technical, the long way to do it. And that should work with any repeating decimal, whether it's delayed or not. But try this. If I have 0.16 repeating percent, I would say split the non-repeating part from the repeating part. Then, do you remember the 0.6 repeating is 6 over 9? 0.06 repeating that's delayed one space, it's 6 over 90. If it were delayed 2 spaces, it'd be 6 over 900, and so on. Ladies. This is 6 over 90. 0.1 plus 6 over 90. And now switch this one to 1 over 10. And get a common denominator. This is 9 over 90. So it should be 15 over 90, which reduces to 1 over 6. Next. Is that it? Seriously?
Yeah.
Everybody feeling okay? Yeah.
Do you have another practice question?
I don't know. Maybe.
Like, that, we can look on and see what question is.
I'll find out in a moment. Yes, I do.
I mean, like, other minutes, like,
Oh,
Yeah.
oh. I have lots of look at third practice test? I do not. Yeah. What you could do, you can make up whatever, tell you what, let's try this. Down there. Yes, I learned to wiggle pen for it when I was in camp. Just to diffuse the situation, here's pen. Stiff.
Oh.
Rubber pen. Stiff pen. The 8-year-old's freaked out when I did that.
It's not even, it's just, okay. Your fingers are moving.
Okay, it actually kind of looks like it's as you kind
No,
of
no, you're like
really
this.
trying and then you can't.
Yeah, I mean, I get it. I just don't. It's not,
Rubber.
it doesn't look like it's amaze me.
Alright.
Rubber.
I've just lost the attention of everybody for the rest of the year.
It's rubber.
Alright, got it. Now then, here's the way to drill for this test.
You're moving your entire arm.
Take a look at the, any old problem you want. Can somebody give me a repeating decimal that doesn't delay? Just off the top of your head.
Like,
Whatever you want. Go.
0.36.
0.36?
Repeat.
Repeating?
Yes.
Okay, was that off the test or was that a new one?
Nah,
Okay. 0.36 repeating.
On this thing here, it is? Yes, it is. Yeah.
26. Whoops.
You want to change it?
Okay, 4, 9.
0.49 repeating?
1, 2.
I got it, 0.9.
You guys are doing squares.
Here's what I would suggest you do if you want to study for this more. First and foremost, Pay attention, put your pencils, your rubber pencils away, please. 0.49 repeating. If you want to drill these, pick your own repeating decimal, or your own repeating percentage. That's, like for example, let's make this interesting. No, let's not make this interesting, let's make it boring. I'll do the interesting one in a minute. Can somebody give a fraction for this? Go.
49 over 99.
49 over 99. Does that reduce?
No.
No. The only thing that goes into the bottom are like 9 and 11. The only thing that goes into the top is like 7. So you're pretty much set. How would you do a percent?
Divide 49 by 99.
You could, although there's a much faster way. Yeah.
You would move the decimal 2 spaces to the right.
Yeah, 49, but what do you put here?
41, 9 repeat.
0.49494949. You can just make that repeat. Again, you can write this out the long way if it makes it look easier. When you write out the long way, it's a lot easier to see what happens when you move it 2 spaces over. Make sense? Now, if you wanted to go backwards, 0.19, let's say 19.19 repeating percent. Can somebody give me a decimal, first of all? You want to?
0.19 repeating.
Yeah, 0.1919, which is basically just 0.19 repeating, see? Again, if you get stuck in any of those, write it out the long way. This is 19.191919191919. And if you move it 2 spaces to the left, you can have a point, 191919191919. Make sense? And then, a question or answer? Okay, fraction.
Fraction?
Go.
19 over 99.
19 over 99.
Uh-huh.
And you're done with that problem. Does that make sense? You can also, again, just pick your own number. It's an educational experience because you'll train yourself in how to write your own test someday. It's not the easiest thing in the world until you get the hang of it. For example, you know, every once in a while I throw a problem in there that's an absolute brain buster. You'd be surprised how easy it is to do that. Let me show you. 0.16 repeating percent. That seems pretty easy. Give me a decimal.
Oh,
0.0016 repeating percent. All of a sudden I've just made it a hard extra credit question by accident. See what I mean? So a little bit of front, by the way, we could do that. This is 16 over, normally it's over 99. You see a delayed 2 spaces with 2 zeros.
wait, what's the percent?
Yeah, because this used to be,
Yeah.
oh, whoops, sorry. Oh, I see what you're saying, yeah, that was a space.
Like that, the first one was hard enough.
Yeah, this one is, yeah, no, that would have been horrible. And then just reduce it, 8 over, whatever half of that is. 49. 49. 50. It goes on from there. And then you can reduce until you finally can't reduce anymore. Awesome, question. Yeah, we're done. Okay, ladies, gentlemen, questions?
No.
Again, if you want to drill, like on the one on circumference, area, radius, pick your own, see what happens. Some of them can get very hard very fast. Some of them are very, very easy. It is a very good exercise to make your own. So I would say if you wanted to drill, take your practice test, look at the decimal, make one that's similar to it but different numbers, and then try it. I can pretty much guarantee that the real test is going to have numbers that are similar to this. Like similar form. Like for example, number 4, they gave you 2 over 11. I won't necessarily put it over 11. It might be over, 22 or 12 or something. But it's something that you can divide out with long division. I will also give you a trick. If you want to find the decimal for this, this is, by the way, this is totally sneaky. If you enlarge this, you can make it 99. Multiply by 9, you get 18 over 99, which is a repeating decimal. That's lucky. If you happen to have something that multiplies up to 99 or 999, you're super duper lucky. Grab it and run. Chances are that will not happen. Questions? That will leave